Welcome back from the ad break, and let's continue with our lesson. So we were representing those numeric patterns in a table and algebraically. So let's continue with that. Now we have that same pattern that we started with in the very beginning of our lesson, and that is our 2, 4, 8 and 16. We did find the next two terms, and those terms were 32 and 64. Now, can you remember how we found those terms? Yes, we did multiply by 2, and that times 2, or that 2, is actually our constant ratio. Now, if you remember, a constant ratio is found by dividing the second term by the first term or the third term by the second term. Now, in this case, that was a 4 divided by 2, which gave us a 2, and which is the same answer as an 8 divided by 4, which also gave us a 2. So our constant ratio here is that 2. Now remember, we were working with the constant difference because we were adding and subtracting, but now we are multiplying. That means we are working with the constant ratio. So we are multiplying and dividing. So let us represent this numeric pattern in a table, just like we did with the other patterns. So our first term there is a 2, our second term is a 4, our third term is an 8, our fourth term is a 16, our fifth term is a 32, and our sixth term is a 64. Of course, we know that that pattern can continue, but our table right now, it requires us just the first 6 terms. But now, how can we represent this algebraically? Now, that pattern is that table is the table that we've already calculated. But now, if we are asked for the 10th term, how are we going to calculate that? Just like we did with the previous patterns, we need a rule. And that rule is going to be obtained by now asking ourselves that what is the relationship between the term number and that term? So let's find the 10th term. But before we can find that 10th term, we need a rule. So in this case, when we are working with a constant ratio, what is going to be our rule? Our rule is going to be a 2. And as an exponent, we are going to have that term number. So that is the relationship that we have seen between our term number and our term. Now, why are we using 2? Remember, 2 is that constant ratio. So as we are looking at our pattern there, we have our first term, our second term, our third term, and our fourth term. And of course, that pattern continues. So as we can see, we know that our constant ratio is the 2. And we can see that for us to find that 2, we just used the term number there, because 2 exponent 1 is a 2, if we remember our exponent topic that we've already learned, of course. And then we can see that the second term there is obtained by using that constant ratio and taking the term number, in this case, that is a 2. And we know that 2 exponent 2 is, of course, our 4. But let us see how this is done. So as we have shown there, our rule will be 2 exponent n. Now that n represents any number that can be there, in this case the term number. Let's see if we can find the 10th term. So we've already seen that from our pattern, we did say that we take our constant ratio and we use our term number, like I'm showing there above, that if we take the third term, constant ratio being 2 and our term number being 3, that is giving us that 8. So for us to find that 10th term, we are going to do exactly the same. So we are going to take our rule, which is 2 exponent n, and remember that 2 comes from our constant ratio. Then we are going to, in the place of n, put in or substitute our 10, only because we are working with the 10th term, and we did say that n is for that term number. Of course, that is going to give us an answer of 1024. You should be getting the same answer on your calculator. Let's move on to the next concept in our concept map, and that is solving problems. So we are going to look at just a few of these number patterns and see if we can solve for them, where we are going to find the rule and also represent them in a table. So the first problem that we are given here, it says in the following numeric pattern, find the rule and complete the table. So we are going to start with that rule. Let's look at the pattern that we have been given. Now, our first term is 3, our second term is 6, and our third term is a 9. Of course, that pattern continues. Now, remember, for us to find a rule, we need to find a relationship between the term number and the term itself. Now, can we see what is going on between the term number, which is 1, and the term itself, which is 3? How about the second term, where the term number is 2 and the term itself is 6? And do you find the same relationship between the term number 3 and the term itself, which is 9? What do you think the relationship is here? Well, it looks like the term number is being multiplied by 3. Because as we can see there in the first term, it's 1 multiplied by 3. In the second term, it is, so let us write this like this. In the first term, it is 1 multiplied by 3. In the second term, it is 2 multiplied by 3. Let's fix that 2 there. And in the third term, we can see that it is 3 multiplied by 3. So we can see that our term number is being multiplied by 3. So what could be the rule here? Well, the rule here could be our term number, which is represented by n, and we multiply that by 3. Of course, that would be written as our 3n. Now, can we represent this in a table? Let's see how we can do that. Now, if we have a table there, of course, the first 3 terms, the first term is a 3, the second term is a 6, and the third term is a 9. Now, what about the 10th term? So, for us to find the 10th term, we are just going to take that term number and multiply it by 3. That, of course, will give us a 30, which means that the 10th term there is going to be 30. What about the 20th term? So the 20th term, that is going to be our 20 multiplied by 3, and that of course gives us a 60. And what about the 100th term? That is just going to be 100 multiplied by 3, that will give us 300. Let's look at the next question. The next question says, in the following numeric pattern, we need to find the rule and again complete the table. So here we've been given a -1, a -5, and a -9. What is the constant difference or ratio here? As we can see, from term 1 to term 2, we are subtracting 4. And again, from term 2 to term 3, we are subtracting 4. So that is a constant difference. And if you remember, we are going to now take the term number, which is represented by n. We're going to multiply it with the constant difference, which is our -4. And we need to find that constant value that we are going to add or subtract so that we can get our first term, our second term, and our third term. So we need to add or subtract that constant value. So we are going to take the first term there, and we are going to say that this first term is going to be our term number 1 multiplied by a -4. And what do we add or subtract to get to -1? Well, 1 multiplied by -4 is a -4. And how are we going to get to that -1? We are going to add 3. Let's use the second term just to check if our constant value is correct. Now that is going to be our 2 multiplied by our -4, and our answer in the end must be a -5. So what do we need to add or subtract to get to -5? Well, 2 multiplied by -4 is a -8. So that, of course, is going to be plus a 3 so that we can get to that -5. So that means that our rule here is going to be our constant difference, which is our negative 4. We are going to multiply that by our term number, which is going to be n, and we are going to add 3, and that is going to be our rule. Let's represent this in a table. So our first 3 terms, that's -1, -5, and -9. And of course, now we need to find the 15th term. So for us to find the 15th term, remember, we are going to multiply that 15 with our -4, and we are going to add our 3. Do you know what the answer is when we multiply a -4 with a 15, then we add a 3? Well, if you have a -57, then you are correct. Let us find now the 25th term. So that is going to be now our -4 multiplied by our 25, and we are going to add 3. What answer are you getting there? If you are getting a 97, then well done. You have substituted correctly and your answer is correct. What about our term 45? Well, if we substitute 45 into our formula, our answer is going to be a -177. Is that the answer that you got? Well, that is absolutely correct. Let's go over to our last question, and we have been given here a -3, a 9, and a -27, and of course that pattern continues. What rule do we see from our pattern? How can we find the relationship between our term number and our term itself? Well, can you see that here for our rule we are taking a -3, and as an exponent we are placing that term number there. Now, how did we find that -3? Well, we can see that from the first term to the second term we are multiplying by -3 so that we can get to our next term, and from our second term to our third term again we are multiplying by -3, and that is where that -3 came from. So what is our rule? Our rule is a -3, and as an exponent we have our n, which is our term number. Let's quickly fill out that table. So we have there the first term as -3, the second term as a +9, the third term as a -27, and what about the 8th term and the 10th term? Of course, using our formula there, the 8th term is going to be a -3, and as an exponent, we are going to place that 8 there. Do you already have an answer for our 8th term? Well, if you are getting 6,561, then yes, you are correct. So our answer there is 6,561. What about the 10th term? Do you think you can find the answer to that? Well, if we substitute 10 in the place of n in our formula, our answer is going to be a 59,049, and that is our answer for the 10th term. Well, that was a wonderful lesson. I really enjoyed it, and I hope you did too. Thank you for joining us, and we hope to see you next time. Goodbye.